Hello!
Hello!
Hello, Mr. Ryan, how are you today?
Good!
Good. Okay, so today we talk about interesting mathematical problem, which is called the complete task. So you're given a list of tasks. Yeah. You're given a list of tasks in numbers, which means the efforts you need, the hours, yeah, you need to complete of that.
Easy.
Yeah. Okay, listen up. Yeah. So for example, like the task. Task. Okay, the numbers meaning the hours you need to complete. Yeah.
What's the hour?
Or the efforts. Yeah. This efforts. For example, like 3, 5, 4, 9. Okay. For example, there are 4 tasks. Yeah. And then there are people. Okay.
Do they
so
have
the people.
to be 4 like me?
People. Okay. So people.
Do they have to equal Ryan?
No, it's a list of.
Juhan?
Yeah, can you listen up, please? The people. Yeah, good question. It's a list of the tasks. So these are the candidate tasks that we need to complete. We may or may not complete. Okay. So the people, like given a list of people, right? And each people has the strengths. Yeah, strengths. So like like 3, 4, 6, 1, like strength.
That's a baby.
And each people, yeah, exactly. And that's Ryan, that's Eric,
And that's you!
that's Daddy. Okay. Okay, so each people can only
Yeah, I
complete.
can be 1.
Each people can only complete 1 task at most, right? When you pick a task, then complete. Yeah, all right. He cannot. For example, if the 6 can complete the task of 3, 5, but cannot complete it with 9. Yeah, because 6 is the strength. Yeah, this is the strength needed to complete the task, right?
Can he do that one?
6 and 4, yes, because yes. But
1 can't do any.
that's right. Yeah. So
I can. How about if it's the same?
It's the same. Yes. 4 can. It just has to be bigger or equal. Yeah.
I'll
Okay.
smash you up and smash you.
Okay. So the problem is, how many tasks maximum can be completed? Okay.
Which one can be?
So for example,
3.
like 3.
I think.
Each people can only complete 1. Okay. Look, Eric. Look. So in this case, how? Let's say 3 can be completed with 3. Yeah. Okay. So I put it. Yeah. And 4 can be completed by 4. Yeah. And 5 can be completed with 6. Yeah. That's it. Yeah. Alright. So 3. But the thing is that, for example, like look, if you if you put this way, Eric, look, if you the 3 task, if you use the 6, right? Yeah. Look, 6 can complete with task, and then 5, then you can't find anything that can complete with 5, right? And you can complete with 4, right? All right. So does it make sense? So we want to find the maximum. In this case, there are only 3. There are 3. But if we let the 6 handle the task 3, then we can't find any people to handle to task 5, right? Because 6 is used. All right. Does it make sense? Okay. So how can we do this? What's your strategy? So if a task can be completed, if a task can complete, let's say if a task 3 can be completed by people 3 and 4, which one you think should pick the task, 3 or 4? If the task requires the strength 3, and we got the people 3 and 4, the strength with 3 and 4, and 2, 3, 4, 5. So which one you think we should let the people?
So it's only the target 3.
Yeah. So we have a task 3, and we have a few people, 4 people who can. These 3 people can handle this, but not the 2, right? Yeah. So which one you think we should pick to let the people? We can assign the task to 3, or assign the task to 4, or assign task to 5. So which one you think is the better strategy?
Because the only task is 3.
Uh-huh.
I don't know it. I think it doesn't really matter.
Okay. That's a good question. That's a good point. That it doesn't matter in this case. But I'm saying that there may be lots of other tasks and then lots of other people. Okay, maybe lots of other tasks. Like look, 3, and then maybe I have 4. I have wait.
Yeah.
Wait. I have a 10 here, and I have
Blah blah blah.
10, and I have
8, 7.
8. Okay, 8, and then I have 7. Okay.
That.
Yes. Okay. So look.
Easy peasy.
Yeah. So look, 3. If I can let the 3 and 8. So it's better to let the lowest people who is qualified for the job, right?
Yeah.
If I let the 8, what happen? If I let the 8 to handle 3, what happen? We don't have.
3 can't handle 7.
3 can't handle 7. So the thing is that if a task is 3, if a task requires effort, strength 8, we want to find the smallest people, the people with the smallest strength that is qualified to handle the 8, right?
Yeah.
Does it make sense?
Yeah.
So coming back to the question, 3 and then 3, 4, 5. So 3 is the qualified because it's the lowest, the smallest number bigger than or equal than 3, right? Am I right?
Yeah.
So it's always the optimal strategy, the greatest strategy, because that if we let the 4, because we know the 3 can handle this, and it's the lowest one, right?
Yeah.
If we let the 3 handle it, then we can have 4, let the 4 handle some job bigger than 3, right? But if we have 4 here, right? Look, if we let the 4 handle the number 3, what happens?
3 can't handle with number 4.
Exactly, right? Okay, so this is the strategy. So in order to do this, what do we need to do? What do we need to do?
Go!
What do we need to do? What do we need to do? What do we need to do?
We need to define.
Complete task. So look, complete task. Okay, and then I have a task, and I have a people, right? Alright.
Yeah.
What's missing?
Condom.
Okay. Listen up.
Yeah.
So the numbers are not in order. So what should we do? What should we do? What should we do?
We shall sort them.
Sort them. Good question. Good answer. How do we sort it? Task dot what?
Sort.
Yeah. What's the time complexity of this one?
Maybe n or maybe log n.
Come on, I told you many times. For the sorting, it's the special complexity. Every time we
Log n.
n log n.
I went log n.
Oh, n log n. Okay. So this
I
is
said it first.
so if
He already
I mean-
said the answer. But I said it first.
okay. So look,
Daddy said it first.
okay. Look. Listen. So the size of these two does not need to be equal. Okay. Let's say the task. This is n task and m people. Okay. So the time complexity for this task is O n log n, and the people is O m log m. Right. Right. So you can choose the maximum or you plus it together because we're not sure which one is bigger. Come on, listen. Come on, listen.
What if
So-
it's already sorted?
But yeah, good question. But if it's already sorted, then we don't need to sort it. Okay. But I'm assuming we need to sort it. Okay. Okay. Good question. Now look. Let's say the answer. Answer is the number of jobs we can complete at the
0.
maximum. Yeah, at the beginning. So
No.
now let's have a 2-pointer. I equals z equals 0. Okay. Right? Maybe let's do it. Look, task equals people equals 0. This is the pointer pointing to the beginning. Pointing to the beginning, which is the what? Smallest, right?
Yeah.
Smallest task, the smallest people, the index, right? Okay, the length. Let's just do it. Why? T smaller than length task, right? Because we haven't run out of task, right? And we haven't run out of people, right? And P is smaller than length people. So what do we do now? We need to check if current people can handle the job, right?
Yeah.
people what? P bigger or equal task T, right? Alright? Alright.
Yeah.
Look, if people can handle this T, then what should we do?
We shall.
Look. It's 1, 2, 3, 4. This is task, right?
We shall add 1 to the thingy.
Yes, look, people, let's say 2, 3, 4. Okay, let's say, look, 1, 2, 3, 4, 4 tasks. People, 2, 3, 4. Yeah?
Then it can't be 4.
Sorry, what? Look, because we already sorted. Okay, now, look, people 2 bigger than 1, right?
Yeah.
Yeah, so we can let the 2 handle the 1, right? Because 2 is the smallest number, bigger than or equal than T. So let's say answer plus equals 1, right? And what happened to T and P? What should we do? The P can handle T, so what should we do after next?
We shall.
We should do what?
We shall.
We should do what? Come on, P and T. I know P can handle T. Now after P and handle T, P.
Here.
Yeah, and then here, what should I do with here?
Move it.
Move it because this I have completed this task. I should move the next big task, right?
Next.
And people I have these people is already taken a job, right? A task. Then I have moved to next people with So what? P plus equals 1. T plus equals 1, right? Alright?
Yeah.
Now look. Okay, so let's see. If this is 0, okay? Let's say if this is 0, people with strength 0, okay? No strength at all. Okay, so what happened? The people cannot handle T, so what should we do now? What should we do now?
We shall move.
Move P, right? We should try next people to see if we can finish, right?
Yeah.
Right?
Yeah.
Okay, so let as P plus equals 1, right? Alright?
Yeah.
And return what?
No.
Yeah? Answer. Come on, answer. Answer is number. Look. So look, there is a P plus 1 here. And there's a P plus 1 here, right? Yeah. We can move it. Look, in both cases, we need to P plus 1 equal 1, right? So we can erase this, and then we put a P plus 1 here. Does it make sense? Because if, then I do this and do this. Else, if this is not equal, not true, then I will do this, right? It's shorter and much better, right? It's the same, right? Does it make sense?
Lots of things at once.
Yeah. Does it make sense, Eric?
Yeah.
Okay, so what's the time complexity of this one?
All of this.
This one, just this one. If it's sorted, you don't need to consider this, but this part.
N.
N is the number of tasks. M is the number of people. O.
N something.
Max. O max. N and N. Which one is bigger, right? Does it make sense?
Yeah.
So which one is dominating if we need to sort the arrays first? This one, yeah. This one. So this one is taking the most time-consuming part in this one. Okay. It's of the algorithm. So this is trivial. Okay. So now. Okay. So if. Okay.
Answer at 1.
Yeah. Yeah, because people can handle this task. And then what should we do now?
T.
Sorry.
T.
Sorry.
T.
T. What T?
T.
T what?
At 1.
N equals 1. Well done. Yeah, let's
T.
not T equal. Okay. Okay, so that's it for today. So this is called greedy, okay? Because we have the greedy strategy. Yeah, greedy is hungry. Okay, that's it. See you tomorrow.
Bye.